Hill.
Hill. And what is the basic physics concept for how gravity works? So in other words, what's gravity? I want you to talk about that. So it says aim, hypothesis, cross that out because we're not doing it. Equipment, background information, method. I don't care if you have method first or background information first. It doesn't really matter. And where I'm going to start today are your results and calculations. Now, if we remember this, sorry, Jack, I have to put that on somewhere I didn't need to do it. So the problem we had with our scales, they measured our masses in grams, didn't they? Whereas we needed to be in kilograms. So to get from grams to kilograms, we need to divide by 100 by 1,000. Kilo meaning 1,000. All right? That's the first thing we needed to do. So I've done that already. I had a ping pong ball. I picked this one from the actual sheet. You guys didn't have a ping pong ball, but it was 2 grams. So I divided it by 1,000, and that gave me 0.02 kilograms. Why do I need to find M? Because it's in this formula. So if I want to work out the gravitational potential energy of my ping pong ball, I take my mass, which is 0.002, and then I times it by G. What is G?
9.8.
Excellent. So we times it by 9.8, and then we times it by the height of our ramp. Now, the other problem we had in this is that our height was in centimetres. 75 centimetres, whereas I needed in, so it's 0.75 metres. And to do that, I divided by 100. So to go from centimetres to metres, we divide by 100. Okay, so that's our conversions, one of the first things we have to do. So this is going to be 0.75, and my number I get is what? What is that? Who's got a calculator? Heidi, you've got one. Who else has got one? I want 3 people doing this, please. So who are going to be my 3? Coops, you're in? Right, Coops, Heidi, and someone else. What'd you get?
0.0147.
0.0147?
Yep.
Joules. Not a lot of energy, funnily enough, but then again, it's only a ping pong ball. If I dropped a ping pong ball off the roof and it hit you on your head, I tell you, you don't feel it. Probably just bounce off. So it doesn't have a lot of energy. So to find EK for the ping pong ball, I first need to do half times its mass, 0.002, and then I need to find this V. So if we remember, yeah.
There's a sticky note attached to the bottom of your foot.
That's cool. I'm just going to walk around with it. It's going to irritate many kids. I can't believe you picked up the sticky note, but not the fantastic new echidna socks. Thank you very much. Anyway, V is going to be equal to 2 metres. Why 2 metres? Because we measured out 2 metres, didn't we? And then divided by our average time. So if I look at that prac sheet and I look at the table, he has an average, well, he's worked out his average speed. But I'm going to say that my time was 2.3 seconds. I just made that up. Everybody clear about how to find average time? I don't need to go through that, do I? You had 3 measurements, so you add them together and then divide by 3. Okay? So what's 2 divided by 2.3, please?
0.869.
0.869, and of course that was in metres per second, because this was in seconds and that was in metres. So I'm going to times by 0.869, and what have I got to do to it? Square it. Okay, so who can tell what they are? What that is? Really? Okay.
0.000755.
0.0075 joules.
Another 0. Yep.
Okay. So, are they the same?
No.
Are they anywhere near close to being the same?
No.
No.
Okay. Well, that's a problem. So, how are you going to do these calculations? Well, basically, you're going to be changing the mass because your balls will be different masses, and you're going to be changing the height because your ramp might have been a different height. In this particular thing, you're going to have to work out V for each of the actual balls and then work out that
You
calculator.
did guess the time.
Can you guess the
No,
time?
you did guess the
I know, I guessed the time, yeah. So it's not as accurate, but remember this. I'm just showing you how to do the calculations. I'm not going to do them for you. So you have to actually do that step. That might be something you work on today. I don't know. That's up to you. So our discussion. Right. In capital letters, write 3 paragraphs. So I'm going to ask you some questions. Do paragraphs have dot points?
No.
Do they have a heading?
Yes.
Yes.
No. No paragraph has a heading. So no practical report should have science paragraph and then things written underneath it. Okay, now I'll let you slide a little bit with that, but not this time. It's not the way I specifically want it written. I'm giving it straight back. Are we clear? So 3 paragraphs, no headings. I'll write it up. No headings. No dot points. Can you have diagrams?
Yes.
Yes, definitely. In fact, a diagram in this is going to make it very, very handy for you to explain some of the principles of why we went wrong with this experiment. So what was the science behind this experiment? What were we trying to prove?
Velocity.
We weren't trying to prove velocity. We were trying to prove that EP was equal to,
EK.
and we know this because of what law?
Gravitation.
No, law of
Energy.
conservation of energy, which states that energy cannot be,
Created or destroyed.
yep, can't be created or destroyed. Everybody happy with that so far?
Yeah.
The science behind this experiment is that we should have found that these two numbers should have been exactly the
Same.
because the law of conservation says it can't be created or destroyed. But why are we wrong? Because what can energy be? It can be transferred or
Transformed.
transformed. So what's happened in this particular case? Why have we lost energy? Have we broken the law of conservation of energy, or did we just not think about something when we did this experiment? Where did this energy go? Who can tell me?
In the errors.
Yeah, so you had errors, but we haven't considered in this. We didn't consider air resistance, and that was a big one, wasn't it? Okay, as the ball rolls down the ramp, what's it pushing out of the way?
Air.
Air. Just think about this. You're at the canteen. Mr. Singline's got one Big Mac sitting in the canteen, and there are a wave of grade 7s in front of you. What are you going to do to those grade 7s? We all know. You're going to push them out of the way. Get out of the way, grade 7s. I'm having that. I'm grade 10. I'm more important. So as the ball rolls down the ramp, it's pushing all these grade 7 air particles out of the way. And when you push something, you lose what? And you lose energy. So air resistance is where this energy is going. So the energy is going to air resistance by pushing these particles out of the way. Where else is the energy going? Did you hear anything?
Friction. Friction.
Friction was definitely one of them. So this was an energy loss. What else? Sound, definitely.
Where do you have this?
Now, if I wanted to represent this, I could represent it with an energy chain, could I not?
Mm-hmm.
So we wanted to go from gravitational potential energy to kinetic, didn't we? But we had energy loss. So how do we represent energy loss on an energy chain?
Downwards.
It goes downwards, yep. So what was our energy loss?
Sound, friction, air resistance.
Air resistance,
Grav.
friction, sound.
Grab
So
hot.
representing it,
Gravitational
Gravitational
potential.
Tripod. So representing it in an energy chain is a really good idea because it's one of the things that we're going to have to do in the test. Is there any other science that we can explain in this particular thing?
No.
So we talked about the science about why we did this prep. So we wanted to prove that EP was equal to EK because that's what the law of conservation of energy stated.
So is this all the science paragraph?
Yeah.
So what background research is?
Background research, yeah.
is what do we want us to research? Yeah.
The background research are the questions I talked about.
These ones?
Yeah, that are sitting under
What
the
are all
triangle.
these?
Are we writing a prac report?
They're questions to help
Yeah.
you write your prac report. Okay, so everybody happy with the science behind what we've got to write?
Mhm.
Okay. Do you want me to go on, or do you want to have a little bit of a crack at writing this?
No, crack.
Crack.
Do you want to have a crack?
Yeah.
I'm going to give you 5 minutes then. I'm going to put some sentence starters up on the board just to get us started. All right? And then you've got to start writing this.
Oh.
Wait. Where's your... Don't copy that because that's not our
I
calculation.
know, it's just so that I can do it later on.
Okay.
Don't want to cover your nose.
Oh, those... I did it to the side.
Who's to the side of you?
No one.
Who says
Okay, guys. Is this the science paragraph?
yeah, these are some sentence starters.
We already put it.
Wait, can we write science paragraph as the heading, or am I not allowed to do that?
No.
You need to write.
How are we supposed to know it's a science paragraph?
Right.
Because it should be the first paragraph every time.
Can my heading be law of conservation testing?
For your prac?
Yeah.
Yes. Yeah,
Okay.
sure.
Thanks.
Okay. So here's a couple of ways that I would start this paragraph. So the law of conservation of energy states, and then I talk about it. All right. The other way you could have started this, in this practical, we were attempting to prove the law of conservation of energy. Another way you could have started this by rolling a ball down the ramp. Our practical was testing the what?
Conservation energy.
Law of conservation of energy. So there's 3 ways in which you can start this particular thing. Now, if you don't want to use those sentence starters, don't. You can do your own. Yes, Tim?
What's this part called?
I would say that on the top it actually says gravitational potential and kinetic energy prac. You could use the heading that's on there, transforming gravitational potential into kinetic energy. It's on your prac sheet. I would all right now get up and grab one of those practicals, especially if you're all struggling to write a discussion. There's one written there that you can help to use. Yeah, sure, bro.
Yeah, man.
Cody, you gonna get one?
That again.
Can we just use the same thing as this?
You're not doing the aim, remember?
What we're doing right now.
Yeah, that's it. Thanks, mate.
Not doing the aim, remember we crossed it out.